So a couple different applications to using radians, a couple formulas we're going to do is, first one is arc length. Arc length. So this formula I'm going to give you calculates, so I've got a circle, and I've got, let's say this is an angle right here, theta. So here's angle theta, radius r. This distance right here is s, arc length. So this, if we took a soft tape measure and measured it around something circular where an angle cuts across that, that would be this linear distance. So to figure this out, we can take the radius times the angle theta. The thing about theta though, the angle, it needs to be in radians. It does not work if we just plug in degrees, because then I have a unit attached to it. The other version of this formula would be that theta would equal s divided by r. So whatever the arc length is divided by the radius, that breaks it up into what that angle would be. So let's say, for example, I want to find the arc length on a circle with a radius of 5 inches, and the angle is 135 degrees. Okay, so I've got radius is 5. The angle is 135 degrees, but remember I said it needs to be in radians. So let's first convert this to radians. So times pi over 180. So, I mean, in this case, I'm going to be looking for actual amount of inches, because I'm going to take 5 inches times whatever the angle is. So I'm just going to put that in my calculator. I could reduce 135 and 180, but I'm going to be getting a decimal answer anyway. So 2.356. So notice 5 inches times that angle, it's going to give me an inch dimension when I multiply these, 11.78 inches. So, and that sounds about right, that if this is a radius of 5 inches, this arc length would be about, 11 or 12 inches. Okay, so notice I can't have any sort of degree unit attached to my angle. Okay. Next, let's talk about speed. And we're still going to use that formula quite a bit, that arc length, with some of these, sometimes with these problems. So, there are two types of speed we're going to look at: linear speed and angular speed. So, with linear speed, this goes back to distance equals rate times time. So to get the rate, we take a certain distance divided by a time. So notice distance is, in this case, is going to be something like inches or feet or miles. And then time, this will be per second or minutes or hours. So when we're asked to find a linear speed, that's what we're going to be doing. We're going to be finding like miles per hour, feet per second, inches per second, something like that. Versus angular speed, now the formula for this, a lot of times we use, this is the Greek letter omega. Omega is equal to theta divided by t, so t is still time, our normal times, but the angle, so this is going to be in radians. How many radians, or so how far in radians we are going to get in a circular motion. So let's kind of compare with an example of each of these. Let's say I'm going to use a car and tires. It's probably one of the more easy to understand problems with these. So let's say I've got a 31-inch diameter tire, and it's moving 6 revolutions each second. And we want to find the linear speed in miles per hour. Miles per hour. Okay, so I like to think of these really as like a converting problem. You know, what I'm starting out with, I might leave a little workspace over here. I'm going to start off with something, do some converting. I want to end up with miles per hour. Okay, so the information I know right now, it's moving, let's see, I've got 6 revolutions per second. So right now I know it's moving 6 revolutions per second. Well, let's take care of the time one for now. There's 60 seconds in a minute. So convert, so that cancel out the seconds. There's 60 minutes in an hour. So now I've got my hour unit that I want. So now I have to change revolutions to miles. So revolutions to miles. And notice too, we haven't used this 31 inches yet. So 31 inch diameter. So that means, here's the tire. All the way across is 31 inches. So a revolution, that's a full time around. So actually, what I can do is use circumference, 2 times pi times radius, or pi times diameter. Let's just do that. Pi times diameter, pi times 31. So my circumference is 97.39 inches. Notice that's just like the arc length formula too. Radius would be 15.5 times the angle is 2 pi. Back to this radius times theta. A full revolution would be 2 pi. So I'd get the same thing, 97.39. So that means one full revolution, throw in another, one revolution, so revolutions cancel, would be equal to 97.39 inches. And now, it looks like I'm going to run out of space. Make some more room. 12 inches are in a foot, and there's 5,280 feet in 1 mile. Whew, that was a lot of converting, but that, I think, I mean, there's lots of ways you could do this, but I think that's the most organized way. You start with the unit, what are we trying to get to, you know, take it one at a time, do the time, then we do our distance, so we're going to be able to get to our miles per hour now. So I'm going to do 6 times 60 times 60 times 97.39, and then my numbers on the bottom, I'm going to hit divided by 12, divided by 5280, because basically numbers on top are multiplied, numbers on the bottom are divided. And probably to be more accurate, I should have kept it going in my calculator, I did not. So, but I'm getting about 33.2 miles per hour is how fast the car would be going. 33.2. That was a pretty challenging one too. A lot going on there. So linear speed key is to keep in mind it's, you know, you're looking for a distance over a time. So now angular speed. We'll do an angular one. Keep in mind it's very similar, but I'm looking for radians, a certain distance around the circle. No unit attached. Okay, so how about for this one? I'll do a car one again. I've got a car. The car is going 65 miles per hour. 65 miles per hour. And the diameter of the tires are 28 inches. Find the angular speed per second. Find the angular speed per second. So when we end up, we want to know, I know radians is not really a unit, but it's like we want to figure out our radians per second. Okay, the thing I know so far, I'm starting off knowing that I'm going 65 miles per hour. So again, let's just get rid of the time situation first. 1 hour is 60 minutes, and a minute is 60 seconds. Or if you use 3600 seconds as your shortcut, that's good. Okay, so I got my seconds. So now, miles. Somehow I have to get from miles to how many radians that is in this case. I see inches. Let's get to inches. 5280 feet in a mile. 1 foot is 12 inches. So now I have to figure out inches to radians. Inches to radians. So again, think about this. We've got a full circle around. Diameter is 28. So I'm going to have to, again, figure out their circumference, because that's going to kind of tell me this distance it's traveling. That's how we figure out speed that we're going, how far around the tire is traveling. So circumference is 28 pi, which is 87.96. Let's go 965 inches. So 87.965 inches. Go a little bit more room. 87.965 inches. Well, that's 1 revolution, right? Well, I don't want revolutions. I want a revolution is 2 pi. So this is kind of an important thing conversion to keep in mind with angular speed. A revolution is equal to 2 pi radians. So that'll get me my radians on top. Again, radians is not really a unit, but that's 2 pi radians. So I'm going to do 65 times 5280 times 12 times 2 pi divided by 60. So divided by 60, divided by 60, divided by 87.695. I should be getting times 12 times 2 pi divided by 60, divided by 60, divided by 87.695, 81.97. So this is how many radians per second.